This is the homework video for 8-41 on H8-1 D2. The directions state to graph each system below and shade the solution region. Let's start out with part A. We have y is greater than or equal to x squared minus 4. So we have a parabola that's been shifted down 4 units. Remember, since we have greater than or equal to, it's going to be solid. So we'll go ahead and graph our parabola. Hopefully you remember how to graph your parabolas. I'm not going into that much detail with how to graph these actual shapes because that is the review part. But we know that our parabola would look something like this. All right, and we'll talk about the shading in just a moment. Let's go ahead and graph the second one, which is just a line. And because it is less than, remember it's going to be a dashed line. So remember this one's solid, this one is dashed, and that's because of the equal sign in it. So our y-intercept is at +1. And then our slope is -3. So we'll go up 3 and then back to the left 1. Up 3, back to the left, up 3, back to the left. And then we'll go down 3 to the right 1. Down 3, 1, 2, 3, right 1. And we will connect these with a dashed line, which indicates that those are not solutions. All right, so now that that is plotted on here, we need to figure out where the solutions to the inequality are. So for our parabola, right, we're talking about all the y values that are greater than x squared minus 4. Well, that black solid line that we have there where we actually graphed the shape of the parabola is where it equals, right? And then all of our y values that are above that, if we put our pencil on the vertex and we go up, right, we're on the greater than side. So it would be all of these points inside of the parabola would make the statement true if we plugged in any of those ordered pairs. Okay, now we also need to identify all the solutions that are less than the line -3x plus 1, and those would be all the ones that are underneath it, right? So if we put our pencil or our pen on our line, right, and we went down, we'd be on the side where our y's are less, right? So we are shading everything beneath our dashed line. Okay, and then you'll see there's kind of an orangish tint. Whoops. That is where our shading overlaps. So if we take this here, right, I'm going to use a green color, hopefully that you can see that. This green region is where our solutions to this system would be located. And how can we check this? Well, we can choose a point from inside that region and plug it into both to make sure that it works. So, for instance here, we'll just choose this point here. It looks like the point -1, 0. Okay, so if I'm going to use that as my checkpoint, I'm going to plug in my y for the y's and my x for the x. So I'm going to say 0 is greater than or equal to -1 squared minus 4. Well, -1 squared is 1, and then when we subtract 4, we get -3. So we have 0 is greater than or equal to -3, which means that that one is correct. And then let's do the second one. We've got 0 is less than -3 times -1 plus 1. That's going to give us a 3 plus 1 is 4. And 0 is less than 4, so that one works. So an easy way to just double check that we've got it correct. Let's do the second one. We have y is less than 2x plus 5. Okay, so remember, since it's just less than, this one is going to be dashed. So I've got my y-intercept at +5. And then our slope is 2, so we're going to rise 2 and run 1. So we'll go ahead and connect this with a dashed line. And then our second one is an absolute value function. Remember, that makes our V shape. And it looks like our vertex would be at -1, 0, right? Because it's been shifted to the left one. So we'll put that point here, and then we'll go ahead and draw in each side. So as we connect those, oops, let's undo that. Come on now, don't do this. There we go. Let's connect it right there with a solid line and connect it here with a solid line. And now we'll look at our shading. So we're looking for everything that is beneath our line 2x plus 5. So we'll shade that one in yellow, right? So everything that's beneath the line. These are all solutions to that first inequality. And then we're going to shade everything that's above our absolute value function, which means, right, if we started on like the vertex and went up, now we're in the y values that are above it. So let's shade in this region. And you can see where the overlap in our shading actually is, right? So we'll go ahead and just cover that with like a green here so that it stands out a little better. And then we can do a check as well with this one. Okay, so let's see. It looks like maybe the 0.02 would be a good one to use. So choose that 0.02. That's in that shaded region. So my checkpoint here be the 0.02, and we'll plug those in. So we're going to say 2 is less than 2 times 0 plus 5, which is going to give us 2 is less than 5. That works. And then we'll do 2 is greater than or equal to the absolute value of 0 plus 1. 0 plus 1 is 1, and the absolute value of 1 is 1. But 2 is still greater than or equal to it, so that one works as well. So that's a quick little review on how to solve systems of inequalities if you needed it. If you have any additional questions, make sure you write them down and let me know, and we'll talk about it later on. Thanks for watching.